to meeting number 23 of the House of Commons Standing Committee on Health. Pursuant to the orders of reference of April 11th and April 20th, 2020, the committee is meeting for the purpose of receiving evidence concerning matters related to the government's response to the COVID-19 pandemic. In order to facilitate the work of our interpreters and ensure an orderly meeting, I would like to outline a few rules to follow. Firstly, interpretation in this video conference will work very much like in a regular committee meeting. You have the choice at the bottom of your screen of either floor, English, or French. Please speak slowly and clearly and hold your microphone in front of your mouth as directed during the sound check. If you will be speaking in both official languages, please ensure that you switch to the language that you will be speaking on the translation icon. That will help the interpreters, and it will help people listening to the feed. So, and this allows for better sound quality for interpretation. Before speaking, please wait until I recognize you by name. When you are ready to speak, click on the microphone icon to activate your mic. And should members need to request the floor outside of their designated time for questions, they should activate their mic and state that they have a point of order. A reminder that all comments by members and witnesses should be addressed to the chair. Should any technical challenges arise, please advise the chair or the clerk immediately, and the technical team will work to resolve them. And if necessary, we will suspend while that happens. Before we get started, can everyone click on their screen on the top right-hand corner and ensure they are on gallery view? With this view, you should be able to see all of the participants in a grid-like fashion. And it will ensure that all video participants can see one another. So I'd like now to welcome our witnesses. So each witness group actually will have 10 minutes for an opening statement, followed by the usual rounds of questions from members. So as individuals, although appearing together, we have Dr. Jerry Wright, Director of the Michael G. DeGroote Institute for Infectious Disease Research and David Braley Center for Antibiotic Discovery. We have Dr. Karen Mossman, Acting Vice President, Research, McMaster University. Our next individual, we have Dr. Carolyn Kwok-Tan, Full Professor, Department of Microbiology, Infectious Diseases and Immunology, Faculty of Medicine, Université de Montréal, Medical Microbiologist and Epidemiologist, CHU Saint-Justine. And we have, as an individual, Dr. Cécile Tremblay, Professor of Microbiology, Immunology and Infectious Diseases, Université de Montréal. Welcome and thank you all for sharing with us your time today. We will begin with Dr. Wright and Dr. Mossman. You have 10 minutes between the two of you. Thank you. Please go ahead.
Thank you, Mr. Chair. I would like to thank you all for inviting my colleague and I to appear today to discuss Canada's response to COVID-19. My name is Dr. Karen Mossman, and I'm the Acting Vice President Research at McMaster University. I am also a professor in pathology and molecular medicine and a virologist by training. Very early on, my team was involved in isolating SARS-CoV-2, the agent responsible for the outbreak of COVID-19. And isolating and propagating the virus has enabled researchers across Canada to better understand the virus and work on potential solutions. At McMaster University, our researchers pivoted very quickly to respond to the COVID-19 pandemic. This includes working on the development of home test kits, leading a national trial for plasma transfusion, and leading a trial on anti-coronavirus therapies. A great deal of work is being done across the university to innovate respiratory ventilators and N95 masks. Thanks to funding from the CIHR, my own lab is currently studying SARS-CoV-2 pathogenesis in human and bat cells. The university is also doing its part as a member of the community. We donated our stock of personal protective equipment to our community hospitals, and our residences are currently being used to host medical residents as needed. Much of our researchers are at the forefront of the global coronavirus research. This pandemic is the very reason why we established our Institute for Infectious Disease Research. We have built infrastructure to respond to crises and outbreaks like COVID-19. One of our researchers with the Institute for Infectious Disease Research, Dr. Don Bowdish, is currently looking at how the immune system responds to infection and will provide insight for the prevention and management of COVID-19 and may lead to potential treatments. I will now pass it over to my colleague, Dr. Jerry Wright, who is the director of our Institute for Infectious Disease Research and who can speak more to the work that is being done there. Thank you.
Thank you very much for the invitation to speak here. Hope you can hear me. This COVID-19 pandemic is revealing what we in the field have known for decades. That is, despite tremendous advances in medicine over the past century, we remain highly vulnerable to infectious disease. We knew this because of the lessons of other pandemics, epidemics, and outbreaks we've experienced in recent memory. These include HIV/AIDS, Ebola, the first SARS epidemic, MERS, H1N1, influenza, and now COVID-19. My own research is primarily focused on addressing the other pandemics that we are simultaneously experiencing, and that is of antibiotic resistance, or AMR. AMR is slower moving than COVID-19, but it has the potential to be even more deadly and create greater economic burdens than the current crisis. I'll return to AMR in more detail later, but at first I want to frame my remarks that I see as a current reality. Despite these past experiences with epidemics and pandemics, we must be honest and recognize that we have time and time again failed to learn that we must continuously support research and development in infectious diseases to be prepared for the next problem. To paraphrase Donald Rumsfeld, in infectious disease, there are known knowns, things we know are a problem, like AMR. There's also known unknowns, things we know that will happen but can't easily predict, like a new viral pandemic, such as the one we're experiencing. And then there's the unknown unknowns. These are things we don't even see coming, like the emergence of prion infections, for example, like mad cow disease, which took us all by surprise. The only way that we can prepare for these eventualities, and they are eventually going to occur, is to support a robust, nimble, and multidisciplinary community of infectious disease researchers in Canada.
Pardon me, Dr. Wright. The interpretation is having trouble. I'm sorry, well, what's the situation with your microphone?
Well, I got these earbuds in that they said were you could hear. Apparently you're not hearing it.
Yeah, I guess maybe try to speak a bit louder perhaps. And do you know which one of the earbuds has the microphone in it?
Yeah, it's this one here.
Maybe take that out and yeah, try that. That would be helpful. Sure. Please go ahead.
All right. So where was I? Oh yeah. So is this better, by the way?
We'll talk for a bit, and interpretation will get back to us if they continue to have a problem.
Okay, thanks. The parallel to fire departments is often made. We as a society support the purchase of fire trucks, the very best and reliable equipment, and employ well-trained firefighters because we learn to be prepared for fires. We value this protection, even though we hope as individuals we never need them, but we sure are happy if we've invested if we do. To be prepared for the next challenges in infectious disease, we need to invest and develop a vibrant community of scientists, clinicians, engineers, and social scientists who will dedicate their careers to solving our current problems and the ones that we know will emerge. However, given the lack of sustained funding in this area, our best and brightest young researchers and clinicians not see great opportunities to thrive.
I'm sorry, Dr. Wright, interpretation isn't on anymore. They're not getting anything. Let us suspend briefly and we will sort this out.
Okay.
So the meeting is now suspended.
Dr. Wright, the
please carry on. We will set your time back to 5 minutes. Please go ahead.
Okay, and again, I apologize for this technical point. I was making the point that there's a significant parallel between infectious disease preparation and fire departments. So, because we as a society support the purchase of fire trucks, the very best and reliable equipment, and we employ well-trained firefighters because we have learned to prepare for fires. We value this protection, even though we hope as individuals we never will need them, but we sure are happy we have invested if we do need them. To be prepared for the next challenges in infectious diseases, we need to invest and develop a vibrant community of scientists, clinicians, engineers, and social scientists who will dedicate their careers to solving our current problems and the ones that we know that will emerge. However, given the lack of sustained funding in this area, our best and brightest young researchers and clinicians do not see great opportunities to thrive by studying infectious disease. We do not have sufficient support to maintain our existing key facilities, such as biosafety level 3 labs that are so important today, let alone expand our capacity in an emergency. I want to be clear that I'm very grateful for the funding that I and my team have received from the CIHR to address the COVID-19 crisis. We're working with a great team of virologists, chemists, and experts in human responses to infection to find new candidate drugs to treat COVID-19. But this is challenging, as you can imagine, in the midst of a pandemic. Had we invested in programs that sought to build these teams and support them in the past, we might have been in a position to lead the globe in this crisis. Canada can and should be leading the world in infectious disease research. This takes me back to AMR, the other pandemic we're now experiencing, a known known. No one can argue that antibiotics have changed medicine, perhaps like no other group of drugs. Antibiotics not only cure infections caused by bacteria, they have enabled much of the progress in modern medicine over the last 75 years by being there to prevent infection. For example, in major surgeries, cancer, chemotherapy, organ transplants, hip and knee replacements, antibiotics are used to make sure that these procedures occur infection-free. Imagine where we'd be without these miracle drugs. It's actually pretty easy to imagine. We'd be exactly where we are right now with SARS-CoV-2, with no therapies and all the devastation that results. Ironically, we may face even more pressure in AMR due to the current pandemic as we deploy more of these drugs to avoid secondary bacterial infections and due to claims of the use of antibiotics like azithromycin in COVID-19 therapies that put pressure on drug supply and derail antibiotic stewardship efforts. We haven't had a new class of antibiotics since the 1980s. And since then, bacteria continue to evolve and have become resistant to actually all of our drugs. And paradoxically, the pharmaceutical industry does not see antibiotics as profitable, and they have systematically shut down antibiotic discovery programs over the last 15 years. At McMaster, we're trying to buck the trend here. Aided by a remarkable philanthropic investments, we created the Michael DeGroot Institute for Infectious Disease Research and the new David Braley Center for Antibiotic Discovery. We built a culture of innovation and dedication to solving the most challenging infectious disease problems we face today, including AMR and now COVID-19. The team is multidisciplinary. It spans medicine, biology, chemistry, math, engineering, computer science, and social science. This is what's essential to respond to future waves of COVID-19 and future pandemics. In closing, I'd like to again express my gratitude for the rapid research funding programs that have been deployed to address the current pandemic and for the unity of the House in supporting these investments. I can assure you that the researchers in our teams that I know include many young people, graduate students, medical students, postdoctoral fellows are working day and night to solve this problem. But what I frankly worry about is that for what's next for these amazing young people. We're our firefighters, and are we prepared as a society to invest in a world-class fire department for them? Thank you, Mr. Chairman.
Thank you, Dr. Wright. We go now to Dr. Kwok Tan. Please go ahead, 10 minutes.
Merci. Alors, je tiens tout d'abord à remercier.
Thank you. First of all, I'd like to thank the chair and members of the Standing Committee on Health for the invitation to testify. I would also like to acknowledge the work of our public health authorities. Both Dr. Tam at the federal level and Dr. Arruda in Quebec are doing work that is second to none. All of them have to make decisions for the health of the population with imperfect data and scientific evidence that is being built up as we go along. I'm a pediatrician and microbiologist, infectious disease specialist, and a clinician researcher at CHU Sainte-Justine, and a full professor in the Department of Microbiology, Infectious Diseases, and Immunology at Université de Montréal. I've been president of the Association of Medical Microbiology and Infectiology Canada. I'm member of the expert group on COVID-19 to the chief scientific advisor, and a member of the leadership group COVID-19 Immunity Task Force. My expertise in both clinical and research settings is in the area of infection control from hospital to community and also extends to the field of immunization. This research theme has been supported since the beginning by the Fonds de Recherche en Santé, Québec. What stands out in the current context is the extent to which infection prevention is generally not crucial, but rather a necessary evil. As early as 2001, the Public Health Act recognized that infectious diseases could pose a threat to the health of the population. In 2005, following the C. difficile epidemic, the Aucoin report, First Do No Harm, Nosocomial Infections in Quebec, a Major Health Problem, a Priority, revealed that successive budget cuts had led institutions to reduce resources unrelated to direct care of users. This had resulted in a reduction in infection prevention and control professionals, which was already insufficient, and in cuts to custodial services with the repercussions we are aware of. The report concluded that there was a need for competent and stable infection control teams and a need to develop and nurture a culture of prevention. As a result of this report, a framework was established in 2006 and revised in 2017. This document recommended that infection control teams conduct, among other things, simulations as part of preparatory measures for the management of outbreaks of virulent or emergent pathogens. It also recommended that facility managers form clinical administrative teams for the management of major or persistent outbreaks to facilitate decision-making and implementation of recommended actions. In this context, the designated infection control officer and the nurse manager of the department were to be given the necessary authority and resources by management, including line authority to stop activities that could endanger people's safety. The framework also recommended that the ratio of infection control professionals per number of beds be respected and adapted to various types of institutions, including CHSLDs. These ratios are one of the monitoring indicators at the department level. It would be interesting to see if institutions complied with these ratios prior to the current pandemic. Despite the conclusions of the Aucoin report and the resulting framework, it must be noted that many recommendations have been pretty much shelved over the years because of a significant lack of human, financial, and material resources, or because they were not considered important enough. Infection control expertise remains central to all health crises and must be included in the mandate of steering and management committees of institutions and networks, and this is not always the case. It is crucial that the prevention officer and the nurse manager be at the decision-making table, along with other directors, not only in a crisis setting. Infection control expertise must be recognized in all settings. The role of the prevention officer must continue to be valued in order to attract quality individuals with the necessary leadership and the will to pursue a long-term career. In addition, health and safety officers are at the heart of infection control and must also be recognized. Occupational health offices are understaffed, making it impossible for them to quickly carry out fit testing of N95 masks and the tracking of workers exposed to COVID-19 cases. Everyone knows the saying, an ounce of prevention is better than a pound of cure. But in Quebec, preventative medicine represents only 3% of the healthcare budget. Infection prevention as a whole has thus suffered from chronic underinvestment. The horrific situation raging in our seniors' residences and centres for the elderly is partly due to the lack of resources for infection prevention in these environments. It's not uncommon that in these centres, the prevention measures have to be reviewed. The Quebec population will be better off. The current pandemic has also highlighted the lack of PPE, forcing advisory committees on infection prevention to take this into consideration in their recommendations. This situation should not have occurred. Following the SARS crisis in 2003, some inventories had been replenished, but others seem not to have been renewed over the years. Furthermore, the inability of our industries to produce PPE and some therapeutics has demonstrated our dependence on other economies. It is therefore vital that we take the necessary steps to address these deficiencies in the immediate future. The increasing complexity of treatment and care and the fragility of our pediatric, neonatal, and geriatric patient population increase the risk of infection, morbidity, and mortality. To protect this vulnerable population from infection, both during their hospital stay and after discharge, we need well-enforced infection prevention and control practices. During this current pandemic, it's clear that a good grasp of infection control concepts would have been necessary in all healthcare settings, but this has not been the case. Despite scientific advances, research specific to infection control is still in its infancy, and grants from the Canadian Institutes of Health Research are difficult to obtain. Infection control projects differ from others in that they tend to be transdisciplinary, involving social sciences, engineering sciences, and basic and clinical sciences. These clinical projects, such as other prevention projects, are often less well recognized than curative projects and do not receive the financial support they should normally receive. Not having invested in understanding how to change behaviors to prevent antibiotic resistance, to prevent respiratory infections in CHSLDs, or to evaluate the effectiveness of wearing gloves in addition to hand hygiene are just a few examples of the shortcomings that undermine our ability to prevent infections, including the current pandemic. Many infection control interventions and recommendations are developed empirically, without solid evidence, which is a major barrier to implementation of recommendations by medical staff. Evaluation of infection control interventions is essential. However, the diversity of surveillance approaches at the Canadian level, combined with difficult data sharing between provinces, make centralization of data at the pan-Canadian level nearly impossible. This prevents the assessment of prevention measures with sufficient sample size to draw conclusions, impedes smooth and rapid outbreak management, and does not allow us to learn from our successes and also our mistakes and learning from them. I applaud CIHR's quick launch of COVID Rapid Research Response Operating Grants. It's ironic, however, that in the context of the current pandemic, clinician researchers in the role of infection control officers who have identified relevant research questions through their day-to-day work have been unable to submit a project as main investigator in the first CIHR competition. They were all managing the pandemic in their respective institutions with a tenfold workload increase. At the same time, CIHR was canceling the March competition and asking everyone to reapply to the regular September competition. However, in the current context, researchers involved in the management of COVID-19 will be at a disadvantage since no preliminary data will be available to enhance the application submitted with a 6-month deadline. Infection control research is essential, whether it's related to COVID-19 or not. It provides the necessary elements for the federal and provincial advisory committees that make recommendations to the departments that will ultimately make the decisions, while allowing for the improvement of techniques and approaches applied in institutions and in the community. In conclusion, the importance of infection control and the research that should support it cannot be overemphasized in order to prevent the development and transmission of infections in the community and in healthcare institutions, including CHSLDs. Adequate investments in this key health sector would have saved lives and public funds. It's important to learn from our past mistakes and take the necessary steps to ensure an adequate and quality infection control system. Infection control has progressed enormously in the wake of the C. difficile crisis. Hopefully, further progress will follow the COVID-19 crisis. Thank you for your attention.
We go now to Dr. Tremblay. Dr. Tremblay, please go ahead. 10 minutes, please.
Well, the committee for inviting me to speak in front of the committee. I am a medical microbiologist and an infectious disease specialist at the Centre Hospitalier de l'Université de Montréal, full professor and director of the HIV Translational Research Chair at Université de Montréal, where I led 2 pan-Canadian cohorts on HIV research. I was the director of the Quebec Public Health Laboratory from 2012 to 2015 and was co-chair of the Canadian Public Health Laboratory Network during this period. Today, I'm talking to you as a researcher, a clinician, and a public health scientist. Let's talk research. First, I want to congratulate the Canadian government's rapid response to the pandemic with the investment of specific funds directed at COVID-19 research very early on in February, and then again in the month of May. There was an urgent need to support research teams already in place in order to advance innovation, mostly in treatment and vaccine development to counter this pandemic. That's the good news. But there is still so much we need to learn to better understand this disease's pathogenesis, as well as to analyze our response to this pandemic and better prepare for the future. To date, the funding opportunities that were launched were short-term opportunities only, less than a year. Yet look at what needs to be done to win this battle. We have to characterize the host responses to the virus. For example, what drives these multi-systemic inflammatory responses and how to treat them? Understand SARS-CoV-2 replication and its genetic evolution over time. Characterize the quality and durability of natural as well as vaccine-induced immunity in various populations, immunosuppressed, elderly, children, and understand the dynamics of pandemics. What went wrong? Can we build tools, models to better predict the next phases or next pandemics? All of this takes time and money. However, as I mentioned, the last funding opportunity was directed at one-year projects only. Over 1,800 applications were submitted, which reflects the interest and innovation potential of our Canadian research community. But only a few of these will be funded. And then what? There are no more announcements regarding future funding opportunities. The Canadian Institutes of Health Research has canceled its spring competition, and we don't know what will happen with the September competition, which is directed at research projects in all domains outside COVID-19. It is urgent to invest more funds for COVID-19 research. The government needs to launch a phase 3 in its COVID-19 research investments. This phase should be directed at gaining 3 things: to get a better understanding in the virus and its complex interactions with humans, to better understand our immune responses, and equally important for the future, to learn the clinical, social, and epidemiological lessons from this pandemic in mid and long term. Furthermore, why not take the opportunity to create a research infrastructure to monitor viral diseases over decades? This observatory would follow a cohort of individuals across the country who would donate blood regularly and clinical data that would become an extraordinary platform to identify, characterize, and predict future zoonotic viral illnesses. I'm now going to switch to French.
From a clinical standpoint, I'm concerned about our preparedness for the phase 2. Do we have enough PPE, swabs, reagents for testing for the fall? What does our stockpile look like? Will we be caught in the same unprepared situation as we were 2 months ago? It is of paramount importance that Canada be self-sufficient in terms of production of these essential materials to manage a pandemic and protect our healthcare workers. The current epidemic has highlighted the shortcomings of our healthcare systems, especially the shortage in all categories of personnel, from nursing aides to maintenance workers to nurses. Governments should reinforce training programs that will encourage young people to be attracted to healthcare professions, be it by scholarship, help to universities to improve programs, or better working conditions to healthcare workers. They are the healthcare system. Finally, we have hardly touched the use of new technologies to manage epidemics. This is 2020. Artificial intelligence research should be at the forefront of research agendas. Tools should be developed to serve public health needs while respecting individual confidentiality. AI should be a research and development priority, and the tools developed should be standardized across Canada to synergize our capacities to control a pandemic. A lot of lessons will be learned from this pandemic. Researchers from all fields, basic, clinical, public health, social sciences, should play a pivotal role in analyzing the determinants of this crisis and preparing us for the next one. Pandemic preparedness plans will need to be reevaluated. I believe it is the right moment to invest in research, to train a new generation of scientists in order to base these lessons on science and to ensure that solutions be anchored in scientific evidence and the reflections of our society as a whole. Thank you.
Thank you, Dr. Tremblay. We'll start our questioning now. We will do 3 rounds of questioning. We'll start our first round with Dr. Kitchen. Dr. Kitchen, please go ahead. You have 6 minutes.
Thank you, Chair, and thank you all for your presentations. They were so short, and I know I wish I could sit down with each one of you individually because I have so many questions, so many angles that I'd love to ask you about. So I'll try and be concise and as I can, and I'll just follow in order of who presented. Dr. Mossman, you talked about N95 masks and talked a little bit about basically not regeneration, but really reutilizing the masks and making them sanitary. And I know, and you may know this as well, that Vido Intervac in the University of Saskatchewan also is doing that sort of thing. I'm wondering if you could comment on that for us, please.
Thank you for that. So we have been working with a number of local companies that have a variety of different devices that they would like tested for the ability to sterilize and reuse N95 masks, because we all recognize that they are in short supply. And so we have set up the ability to have both our engineering faculty members ensure the integrity of the masks. So if they go through, and it's different types of sterilization, that they maintain the integrity. And then we have a number of our virologists testing that the methodology will actually properly sterilize the mask and kill the viruses. Our engineering faculty are also working on looking at different types of materials that could potentially be used to generate also sufficient types of masks.
Great, and that was actually my next question too, was on the aspect of, it's not just the N95s that we're looking at, because N95s are more specific respirators versus other masks where we see a lot of people using those and the material that they're using, making sure that how much it protects it. Because the 95 really, as you're aware, indicates purely the percentage of microns that it minimizes, correct?
Correct.
Pardon me, Dr. Mossman, the interpretation is having a bit of a problem. Can you be very careful to speak slowly and clearly and loudly? Go ahead.
Okay, thank you. Thank you, Dr. Mossman. I appreciate that. Dr. Wright, you talked about AMR. And I think a lot of people, especially on committee, are probably I have a background in it, not a great one, but I do have one. And a lot of people on the committee may not be aware of it. But when we're talking of antimicrobial research, and we're talking really about four things, basically protection from bacteria, fungi, viruses, protozoa. Ultimately, the research is not there, as you've indicated. The concern is that we have people going into long care facilities, into hospitals, where the hospitals are using materials, disinfectants, in my opinion, not to the strength that should be, such that they're actually not protecting the public when they go to these facilities. Is that the area that maybe we should be focusing on a little bit more, as in particular where we see, where we've had long-term care practitioners who are only going to one facility now instead of others, that they're now changing their clothes when they get there, they're wearing their clothes in the work, then changing back to their street clothes, et cetera. Could you comment on that, please?
Well, certainly you raise a really important point, and that is, as healthcare workers move between facilities, they take with them any organisms that are on them, so any bacteria or viruses that they happen to be in contact with, and they can transfer them to other spots. And then, in fact, this is one of the big challenges with antibiotic resistance, in that these bacteria can move around on people, and on other surfaces. So it is an issue, and I think we have to be very aware of. I'm very happy that we're at least in Ontario, I think we're trying very hard not to have people move around between these facilities, because I think it does present an unnecessary risk.
Great, thank you, Dr. Quach-Tan, and thank you for your presentation. It's tremendous, and I look at your research, and I'm interested in a number of things in that. But first of all, I just want to touch on, we go back to the issue of 2001, 2005, where we were looking at infections. Started up with the concept of infectious control teams, and over time, and I think you're alluding to it, is the fact that we've been left behind. In fact, many of our witnesses have indicated that things that we were brought up have not been followed through. For example, the research is one that sort of got for 1 or 2 years after the SARS epidemic, and then all of a sudden it seemed to be forgotten. But you talked a little bit about infectious control teams and doing simulation ratios, and I think that's part of what PHAC was supposed to be doing. But I'm wondering, do you know how many actual simulations have actually been done since, as you mentioned, 2005?
So it's hard for me to speak at the Canadian level. That responsibility lies, yes, on PHAC, but also on provincial public health institutes. Correct. And also on hospitals. So I know that at the Canadian level, there has been simulations around pandemic, whether it was around Ebola, they did one around pandemic H1N1, the influenza, and they were supposed to be doing another one now, but the real thing happened before simulation could be done. At the level of our hospitals, I think that most of us have done one or two, whether doing Ebola or now with COVID, but it's not something that we do on an ongoing basis because it requires resources, time, as you can imagine. And so, yes, absolutely, we should be keeping that in mind and doing more of that so that we're not taken up by surprise when something like this happens. In my hospitals, we've done some. I was at the McGill University Health Center before, and we had done also, but it should be somewhere on a checklist where you should be doing them every year or every other year, just to make sure that you know how to think through a new pandemic or an outbreak.
And that's an important.
Thank you, Dr. Kitchen.
Okay, thank you.
Dr. Quach-Tan, we need to find a Goldilocks point for your microphone. It's a little too close now. Just move a little bit further away, because when you're speaking now, there's popping and so forth. It's difficult for the interpreters. So we go now to Mr. Van Bynen. Mr. Van Bynen, please go ahead. You have 6.
Thank you, Mr. Chair, and thank you to all of our witnesses for joining the committee today and for sharing their valuable expertise. I've heard of a lot of collaboration happening out in the field, and I'd like to learn more about the virus and to find the potential treatments to develop the vaccine. So, Dr. Mossman, I understand that your findings were a product of collaboration between Sunnybrook Hospital and University of Toronto. So I'm wondering if the amount of collaboration that we're experiencing during this pandemic is something that you've experienced in the field prior to the pandemic, and are there any challenges that you're facing with respect to collaboration?
So we are very fortunate that we have really strong collaborators, especially within Ontario and within Canada. So even at the initial phases of when COVID first started in Toronto and we were working with Sunnybrook to isolate the virus, it was a very natural and very quick collaboration. What I am seeing that is different as we move through the pandemic is the international collaborations and the willingness of scientists to share information before it is published. So that is fairly new. But we were able to very quickly collaborate, and I think it's that Canadian spirit that we have phenomenal collaborators. So we have not seen any challenges with collaborating either with our colleagues in Toronto or across Canada.
And so how can the federal government foster a more collaborative or innovative environment between research groups in order to find and support future treatments for the vaccine for COVID-19?
So one mechanism that has become very useful is the Can COVID platform. So that is a platform that is now linking all of COVID-based researchers in a number of different areas. That's very expensive to maintain. I know there have been discussions with having the government help fund initiatives like that. And so that platform, the Can COVID platform, really helps to, if you don't know who the right collaborator is or who you should be asking the question to, that allows individuals and individual researchers to find the collaborators and to initiate conversations. And so that has been a really, really excellent resource. And that is something that, funding resources like that can be very, very helpful.
Thank you. Dr. Wright.
Pardon me, Mr. Van Bynen. I'm having a little trouble with your sound quality. I'm not sure if your hand is brushing the mic or not, but be extra careful, please, to speak slowly and clearly, and it's pretty much into the microphone. Thank you. Go ahead.
My next question is for Dr. Wright, and it's my understanding that you've received funding from the Canadian Institute of Health Research as part of the government's investment to fight COVID, to support medical research focusing on targeting genetic and chemical vulnerabilities of the virus. So could you share with the committee a bit more about your research and how it is supporting the development of treatments for COVID-19?
I'd be very happy to. And again, let me reiterate how grateful I am that we were able to get that money out very quickly, as both of the other witnesses mentioned. So this is a collaboration. You were talking about collaboration before. It's between a virology lab headed by Dr. Matt Miller in our institute, as well as a human cellular biologist, Dr. Mike Tyers, who's at the University of Montreal. So this is we're trying to tackle the problem from trying to find drug candidates for the virus itself, as well as to address issues like, for example, entry of the virus into cells. So we could think of drug cocktails to be able to kill the virus and prevent infection. So we are running. We have at McMaster, we have a small sort of drug discovery platform very similar to what you would find in a pharmaceutical industry that we've developed over the years with the support of federal and provincial governments. And that's what we're deploying to be able to do this, to try tackle at once the virus and the human cells on the other side. And because of the advances that Dr. Mossman's group has been able to do, we have SARS-CoV-2 in our biosafety level 3 facility, and we're able to test those drug candidates on the virus directly.
Great. Now, we know that hand washing is ideal, but it's not always available as options when you don't have access to soap and running water, which means that you may not have any choice but to resort to hand sanitizers. I'd like to hear your thoughts on if there's any way of avoiding antimicrobial resistance, but while still protecting yourself with the COVID-19.
Oh, certainly. So the best way to do that is to use hand sanitizers that are done alcohol and not the other compounds that have the ability to select for drug resistance. So as far as we know, so far, alcohol-based hand sanitizers have no effect at all on selection for resistance. And those are the ones that we should be using. In fact, they tend to be deployed in almost all healthcare facilities.
Thank you, Mr. Van Bynen. We go now to Monsieur Theriault. Mr. Theriault, please go ahead. 6 minutes.
Thank you.
Thank you, Mr. Chair. I would like to thank all the witnesses for their contributions in trying to find solutions. That's what we're after. Dr. Quash and Dr. Tremblay, I would appreciate your intervention. Let's do some background. We don't know too much about the virus. We don't have any vaccines. And since we're talking about getting out of confinement, some are saying we have to learn to live with this virus as we learn to live with AIDS. So we're going towards antiretrovirals. We don't yet have significant ones. We haven't yet deployed in optimally some of the serological tests. We are not self-sufficient in our country. The healthcare systems are slowed down. Some healthcare sectors are contaminated. Frontline workers are sidelined because they're contaminated. We don't know much about the quality, the durability of natural immunity. Given all of this, we must have to do everything to flatten the curve. What is the safest level of deconfinement? Is Quebec on the right track? Or are they following the same track as countries that have had to reconfine people? Is that Cecile, or should I go? Well, maybe I should start. Who are you addressing the question to? Well, both of you. Well, what is the acceptable rhythm? I believe the conditions that were proposed by the World Health Organization to manage or planning the confinement, it seems they're not unacceptable. To have a drop in the number of new cases over 14 years and then put in place all the conditions, the capacity to prevent traveling outside the country, etc. In Quebec, we have two different pandemics, the Montreal area and the rest of Quebec. The conditions were pretty much met in the rest of Quebec, outside of Montreal. For the Montreal urban area, there were some delays in meeting these conditions. And even now, we see there is a slight drop. There is some leveling off taking place, but there is still the risk that if deconfinement, which started today, isn't done in an orderly manner, if we could start having more significant numbers of daily cases, if they're higher than what we would hope, they could set off other cases around the area. I believe that generally things were well done in terms of the conditions that were implemented for deconfinement. But in the Montreal area, we have to look into the situation very carefully over the next few weeks. Dr. Quash, yes, I agree with what Dr. Tremblay has just explained. I think in the Montreal area, we have to pay particular attention. The rest of the province is quite stable. But if you look at the Montreal region, the transmission, it's not everywhere in the Montreal area. This virus, unfortunately, has stigmatized the most vulnerable populations and has brought to light some of the social inequalities that were already evident. So it's areas in Montreal that are hard hit compared to others. One of the reasons why some of these measures have been relaxed is because we had to try to relax measures instead of asking people to stay at home, knowing that people were already stepping outside the house. I believe it's a difficult challenge to take up. We have to follow the situation very closely over the next couple of weeks. So it's time management. We are aware that we are not yet self-sufficient in PPEs. We have outbreaks in some hospitals. We have outbreaks in long-term care facilities. From now till the next week, we're always talking about this next or second wave. And maybe we can better prepare this second wave. Is there danger that is deconfinement, that people are getting out of the house? Are you worried about this? We don't have too much time. There is only 3 months left before we can start projecting the second wave. Yes, we are trying to buy time. Yes, the second wave can occur in the fall when children get back to school, when there will be full activities back in place. What we have to do is reduce close contact. What we have discovered with this virus is that transmission to take place requires a fairly close contact and fairly prolonged contact. So transmission outside is done much easier than outside. So it's probably safe to allow people to step outside, asking them to maintain the 2-meter distancing. But I think that with a drop or the increase in temperatures and humidity, the virus is probably less resistant. So the transmission should not occur so easily. We must have to learn to wear masks in public, not necessarily outside, but when you go into confined areas where it's impossible to maintain the 2-meter distancing. As you said earlier, we have to learn to live with this virus. We're not going to get rid of it tomorrow morning. We must expect the right medication or vaccines to become available to provide protection to a broad spectrum of the population. So we have to reduce the transmission as much as possible. We know that it will occur. Transmission is, we're trying to make sure that we have very few numbers.
Mr. Davies, please go ahead. 6 minutes.
Thank you, Mr. Chair, and thank you to all the witnesses. To whichever witness feels best qualified to answer, what is the most current state of knowledge information concerning immunity? Are we getting closer to understanding whether or not once we're exposed, immunity is conferred, and if so, how long that might be for?
I can start if others may add. So right now, what we know is that most people who have been infected will develop some kind of antibodies. The titer, so the amount of antibodies and the quality of these antibodies is not known for sure. It may vary from one person to the other. It may vary on the type of exposure a person has had, whether they've had a severe disease or whether they've had a mild disease. In which case they might not mount a very big immune responses. So the jury is still out in terms of the quality of the immune response as to whether it is really very protective against a reinfection. But we can assume that probably it would be somewhat effective against reinfection. What is less known is the durability of this immune response of these antibodies. In most coronavirus infections, there was a recent study that was published last week. The they evaluated immune responses over a period of 35 years in 10 individuals, and they mapped all their coronavirus infection. And so they came up to the conclusion that the immunity was between 6 to 12 months of lasting immunity against a coronavirus infection. So this is a problem because it's not a very long lasting immunity. And if we want to rely on herd immunity, it would take forever to for a society to be 70% totally immune against these type of viruses. So that's where we are right now.
Thank you, Dr. Tremblay. I'll stay with you and direct another question to you. In May 7th, you called the failure to test people who might be asymptomatic COVID-19 carriers a, quote, missed opportunity. Given that epidemiological modeling has suggested that asymptomatic or preclinical cases may be responsible for potentially significant transmission of the virus, what do you think of, I think it's the governments of Ontario and I think even Quebec, who so far have declined to test asymptomatic individuals. What would be your comment on that?
Well, for the last week or so in Quebec, since they've increased the testing numbers, they have allowed for testing asymptomatic individuals. You know, there are two ways of seeing this. If you go randomly in a population and test anybody who's asymptomatic, it's not really worth it because you're not going to find that many who are positive. So that is not a good way to go. But on the other hand, if you have a person who is infected and has several contacts, some of which are asymptomatic, I believe they need to be tested, and it is very important. And it should have been done earlier, in my opinion, to test the asymptomatic contacts of symptomatic people.
Thank you. So again, generally to everybody, I'm interested in the most current state of knowledge on transmission. We know that COVID or the corona, I should call it SARS-CoV-2, is transmitted definitely by droplets. What do we know right now about its transmission by aerosols or fomites?
So I'll take this one if you don't mind.
Please.
What we know is that in certain circumstances, particularly when you're in a hospital and you do medical procedures, you might be able to aerosolize that virus. For instance, if you intubate a patient, if a patient is on CPAP, so when you go in the airways, absolutely, we know that aerosolizes the virus. And so that's why we put them in negative pressure rooms. We wear N95 masks and the rest. What is still not completely clear is what happens when a person coughs or does physical activity and breathes out very strongly. I think that what seems to happen is that you are able to have smaller droplets that will be suspended in the air for 5 to 8 minutes, but it's not per se for now an aerosol. So studies are currently ongoing, particularly in long-term care facilities, where we're all wondering if airborne transmission is not happening, given the proportion of people who become infected when they just go into those facilities. And so air sampling are being done with cultures of air. We know that we are able to find pieces of viruses in the air, also in long-term care facilities, but we don't know if that's a piece of a virus that's dead or if it's actually a virus that's still able to replicate. So the studies are ongoing right now, and I think we'll have the results within the next month or so. And at that point in time, we'll know. But at this point in time, I think daily living will cause droplets that may be suspended in the air for 5 to 8 minutes, like when you sing, for instance, and when you cough very hardly, and that is still able to infect the next person. But an aerosolization per se for now is not yet approved on. The jury's still out, as Dr. Tremblay would say.
Thank you.
8 seconds.
Thanks, witnesses. I'll see to the next questioner.
Thank you, Mr. Davies. We start now round 2. We'll start round 2 with Mr. Généreux. Mr. Généreux, please go ahead, 5 minutes.
Thank you, Mr. Chair. Dr. Tremblay, if you can get a good idea on what our national stockpile looks like, please share. We're certainly trying to get that information over and over again at this committee. So perhaps something we can follow up on after this this meeting. The question I want to ask, and probably start with you, Dr. Tremblay, is a follow-up on the question from my previous colleague just asked with regards to immunity. And the question we receive often is whether people build immunity to the virus once infected. And so in a bit of a different angle to what my colleague asked, has there been any progress in answering that specific question? And have we seen an example of where people have become reinfected with COVID-19?
Well, a lot of labs are working on that to evaluate the quality of the immune response. We can take for granted that there is some kind of immune response, and some antibodies are being made following infection. We just don't know exactly the quality and the strength of these antibodies. Are they neutralizing antibodies, so the kind of antibody that can really kill the virus when they meet the virus again, or they're just binding antibodies? So we still don't have the answer for that. But as far as being reinfected, so there have been a few case reports suggesting that some people might be reinfected. But what we don't know so far, and we think it's most probably a person who had been infected, the virus was not totally eliminated from their body, although they were not detectable in a couple of PCR tests. And then a few weeks later, they become detectable again. Most likely, it's probably the same disease, but to date, we haven't had a study that can definitely rule out that there hasn't been any reinfection. But if it is rare.
Great. Any other witnesses want to weigh in on the ability to build the immunity to the virus? Dr. Quach, I was thinking specifically.
Yeah. So again, we don't, as Dr. Tremblay just said, there are still so many unknowns around this virus that we know that there is an antibody response, but we don't know how long that will last. I think if you were to look in the last rapid response COVID-19 CIHR grant, you'd find a couple of people putting that particular question in so that we're able to actually have an answer to it. And as Dr. Tremblay said, most of the people we've seen with relapse positive PCR were likely a same patient with undetectable PCR that became positive again. We had a patient like that who was positive for like 65 days with one bit in between who was negative and where the virus never grew. So we're not exactly sure why this virus hangs around for so long, but it does. And it doesn't mean that they're still infectious though.
So I guess we keep hearing that until there's a vaccine, the normal life in terms of social distancing we'll have to keep this social distancing up. Is there a another path that you guys see without a vaccine that this I see a few you already shaking your head without this being able to relax some of the social distancing? Is there any, maybe Dr. Quach, begin with that?
Well, you can, but then what happens is that you're going to have a huge wave. Your healthcare system is going to be overwhelmed and you're going to look like the US or Italy. So yes, there's always the way around it. But until we have a vaccine or we reach herd immunity, which will not come anytime soon, you have to maintain social or physical distancing, at least, if not social. Otherwise, we're going to transmit it to one another.
Right. Dr. Tremblay?
Or if we have a treatment, that would be good too, because this is not like unlike HIV, was a virus that enters the host genome and then stays within the person. This is an RNA virus, so it's like wimpy compared to viruses like HIV. So if we could have a good antiviral that could reduce its replication and render it much less virulent and that within the person, that could help too. But outside of that, it's going to be the social distancing.
Great. So committee members have often been directed to public health agencies, public available data for up-to-date information. Is that the same information that that researchers are using? I think I have very little time, so yes or no.
Yes.
Probably.
Yes, we have nothing more.
Yes.
Thank you, Mr. General. We go now to Mr. Fisher. Mr. Fisher, please go ahead, 5 minutes.
Thank you very much, Mr. Chair, and thank you so much to all of you brilliant minds for being here today and to share just a little bit of your wealth of knowledge. Dr. Wright, in your conversation with MP Van Bynen, you talked a little bit about how the COVID-19 pandemic could contribute to the rise of AMR. On the other side of that coin, are there any aspects of this response to this pandemic, I don't know, increased infection prevention or control measures in hospitals and other settings that might help to combat the rise of AMR?
That's a really good point, and we don't know the answer yet. Everything is theoretical. So on the one hand, we're concerned about selecting for more drug resistance, but on the other hand, because everyone's all of a sudden washing their hands properly and wearing masks while out and about doing their grocery shopping, the amount of contact that people would normally have with other organisms is decreasing. So the jury's still out. I think inside of hospitals, we're always going to be nervous about drug resistance, but out in the community, I think we might actually see a decrease. But like I said, the jury's still out yet.
Well, I'll tell you, I'm a politician and I haven't shaken a hand since March 11th. So you're absolutely right. Sticking with the hypothetical, Dr. Wright, if the worst were to happen and the virus never goes away, if it becomes endemic in our communities, how would you change how people prepare for a second or a third wave? So if hand sanitizers create a future risk, what would you recommend in how we keep our citizens safe?
Well, I think we're doing it right now. We've proven how to do it. We've shown how to do it. We're getting very good at the new normal, which is this physical distancing between people to avoid these things. And like I said before, hand sanitizers aren't necessarily a problem if they're alcohol-based. People washing their hands, washing door handles, and all sorts of things that are happening much more in our institution than they used to. Is the way to prevent the infection, and short of as Dr. Tremblay said, short of a new drug cocktail that you could preventively take if you were exposed, and that's probably going to be our first way out. By the way, not a vaccine, but some collection of drugs that you're going to be able to deal with. I think that's going to be the new normal for all of us because it's happening to us. I mean, I'm in my basement. I'm not at work. So,
yeah. Dr. Mossman, your research is fascinating. Congratulations on your grant. At what stage are you at in your research right now? I don't think you had an opportunity to sort of fill us in on where you are today.
So we're really interested in understanding the pathogenesis of this virus. And so we're starting to learn what cell types the virus can actually enter in and replicate in, what cells are permissive, and we're looking at immune cells in particular. So we're starting to understand a lot about just the biology of the virus. And then part of the lab is very interested in comparing human cells and bat cells, because bats, of course, can carry all of these viruses and not get sick. And so we're starting to understand those very, very small changes because bats are mammals. Their immune system is very similar to ours. And we're starting to understand what those very small changes are. And now we're going to work with colleagues to try to come up with mechanisms, be it drugs or small molecules, that we can change the human system into the bat system so that they would be protective.
Any more time, Mr. Chair?
You have 50 seconds.
Okay, last week we had Canada's Chief Science Advisor, Dr. Mona Niemer, in our committee, and she talked about the importance of promoting open science. I know, Dr. Mossman, you've talked a little bit about that, but I'll go to anyone else who would like to answer, what specific steps have researchers or universities taken in order to share that data?
Well, aside from many of our researchers now putting their findings online before or during the process of peer review. There's many mechanisms now to put your research online. McMaster has also signed an open COVID IP pledge that will say that any findings that we find, the intellectual property will be available for a period of time, such as a year, just to ensure that people can use our findings. And it's about the greater good rather than any sort of monetary or commercial value. So
that'd be a big change since 2003 with SARS, right?
Thank you, Mr. Fisher.
Absolutely.
Thank you.
We'll go now to Mr. Weber. Mr. Weber, please go ahead, 5 minutes.
All right. Well, thank you, Mr. Chair, and thank you to all our presenters today for your opening comments. I want to talk a little bit about the research grants that are available out there. Dr. Mossman, you talk about your funding and how that's being provided by the CIHR. And Dr. Wright, you are very grateful for the funding that you're getting, according to your testimony here. Dr. Tremblay, you congratulate the government for the money that they put toward research. Although you mentioned short-term funding opportunities are the only available research dollars for short-term funding, and you see no more future announcements for funding. The committee back in April 14th, we heard that the CIHR, in collaboration with the provinces, were able to invest $54.2 million to support COVID-19. And on the 23rd, our committee heard that an additional $115 million in funding was allocated as part of a $1.1 billion national medical research strategy for COVID-19. So hearing from all of you today, some of you are grateful for the funding you're receiving, others are not so. Dr. Quash, you mentioned that it is difficult to obtain grants from the CIHR. So I'm just a little bit confused here. Are some of you happy with the research dollars and others are not? How many more billions of dollars do we need in order to satisfy the researchers in Canada? I guess I'll start with Dr. Quash Tran, please.
Well, I think as researchers, we would always want more money to fund research. I think that question, you knew the answer by asking it. I think it's the variety of research that is currently happening that makes it so difficult for all the good research to be funded. I mean, if you look at the scores currently, some grants that have scored in the first, above 4.0, which is amazing, are not even funded. I understand the competition and I understand all of that, but it depends on how the committees are seeing the importance of each question. As I said, I think that prevention is usually not as sexy as a cure or genetics. And so it's not as easy for all the topics to actually float to the surface, regardless of how well you write it. I can't tell you how much money we want. I can only tell you we want more.
You want more.
But I don't, then it's a political decision. It's not ours to make.
Yeah, exactly. What areas of research should be prioritized in your view?
Well, as I said, I think if you want...
Pardon me, Dr. Quach, could you hold your mic up, please? Not too close to your mouth, but just hold it up a little high.
Yep, sorry. So I think that if I was talking for myself, I'd say I want infection prevention to be highlighted.
A little bit farther away.
Okay. It's a tricky microphone here. So, but I think all the domains need to be actually funded. And the problem is you never know what research is done today will help you tomorrow. And so when people developed and invented the laser, they didn't know what they were going to do with it. And at one point in time, it became trendy and people were able to use it. So to be able to tell you now what needs to be funded is impossible. I think the research community just needs to keep an open mind to all the projects that are coming up, including very, obscure basic science project, you could say, where you don't see an applicability today, but which could be the lead of the future. So,
Yeah, thank you for that. Dr. Tremblay, can you give us a better idea of the limitations of short-term funding and the advantages of short-term funding? And do you have some examples to share there?
The advantages of short-term funding is what you've seen so far is that giving right away money to test new drugs and start the vaccine development process, that was very important, and that was done. What is useful in long-term funding is what you do next. Like, for example, we need to know the durability. We need to be able to prepare for a new pandemic. So how do we monitor the viral illnesses, zoonosis that comes from animals to human over time? When after SARS-CoV, so there was a push for research during SARS-CoV, and then nothing more. So it left in the middle the research that was in development for a vaccine, and that was never completed because then it was not popular anymore, and it was not à la mode. So you need both. You need infrastructure that will allow us to be prepared for any kind of viral illness that can come and that will be useful for all researchers. And you need also to have specific research programs that are not solely, that are multidisciplinary, that can lead to collaboration, that can eventually lead to innovation. Correct. There hasn't been $1 billion put into research for this pandemic. It's the 115 million. And just to fund one clinical trial, it's $5 million. So just to give you an idea of how little you can fund for $150 million. You've got 5 clinical trials for vaccine, and a third of your money is gone. And you haven't started looking at prevention of infection. You haven't started looking at more basic immunity or other stuff. So you don't go along with unfortunately, with 150 million.
Interesting.
Thank you, Mr. Weber. Dr. Jaksic, over to you. 5 minutes, please.
Thank you, Chair, and thank you to all the witnesses for explaining your area of research. It's really fascinating to see all the little pieces hopefully coming together. I'd like to start with Dr. Tremblay. I was very interested in the cohort that was followed for some 35 years and apparently showed very limited or short-term immunity to coronaviruses. In your view, why would a vaccine necessarily be different in terms of allowing for continued immunity?
Well, when you design a vaccine, you design it to produce antibodies that are very specific to the antigen you want to attack. And when you test it, you use candidates that will likely generate high levels of antibody and with a very high potency for neutralization. So because you were engineering it, you're developing it, so you can choose what type of antibody response you want to get from that vaccine. So when these researchers looked at the overall, what was the duration of the immune responses, it's like, as I was saying before, the immune response is not equal from one person to the other. Some of them have very weak immune response. We don't decide what kind of immune response we're going to have. It depends on our genetics and all kinds of virus-host interactions. But when you design a vaccine, this is what you're looking for, and you're engineering it to produce long-lasting. And you can also, if you're not successful in producing a vaccine that has a very durable response, you can also boost it, give booster doses. And because it is an infection that is not a virus that does not integrate our host cells, even if you need to give 2 or 3 boosts for the vaccine to be efficacious in the population, it can still be done in a year or 2 years time frame and then be successful in eradicating the virus.
So you do remain optimistic, essentially, that
Yes.
there is a solution with a vaccine.
I am. I'm actually very optimistic about the vaccine.
Thank you. Dr. Mossman, I was very interested in reading a little bit about the research that you've done, understanding the interactions between viruses and their hosts. Now, one of the issues with COVID-19 has been that, in fact, presentation of symptoms has been quite varied from individual to individual, to the extent that even though there is a national case definition, some provinces have sort of tweaked it as more and more becomes known. From your perspective, looking at host cells, as you have explained to us, what exactly are you learning about this particular virus and the variation of presentations? We've heard from Genome Canada, just to give you another little piece of background, in terms of the virus mutating and therefore changing as time goes on, and potentially even that an individual's genome might receive the virus differently. So could you just comment on that?
It's a fascinating field because you have to look at both the evolution of the virus, but also the evolution of the immune response against the virus. And in many cases, it is that back and forth evolution. And so, what we're learning is we know quite a bit from the original SARS as well about what receptors on the surface of a host cell or human cells allow the virus to bind and to get in. But we're also learning that there's more than just one. And so now that we recognize there are, some cell types that don't express the protein that is normally the receptor, it's becoming more interesting to understand what are the other receptors, what particular cell types is that protein on? And that starts to explain some of the other symptoms that we're seeing. Some that, we have indications of gastrointestinal potential, and it's still being tested, but we certainly at McMaster, and I know of others, are looking at the possibility of transmission in live virus, for example, in feces from the gastrointestinal tract. So as we understand more about, what cells the virus can get into, and some cells, the virus can't make copies of itself, but the cell will still respond. And so the cell can still make certain cytokines that will show symptoms, or that can induce certain symptoms, even if that cell doesn't allow for viruses to make multiple copies of itself. So, the more we get to understand the biology, the more we're starting to very slowly understand some clinical symptoms.
Thank you, Dr. Jaksic.
Thank you.
We go now to Monsieur Thériault. Mr. Thériault, please go ahead. 2 minutes and a half, please.
Well, a simple question. Well, you've said that we have to share information almost in real time. But Montreal has just decided not to make the wearing a mask mandatory in public places, including buses. So what do you think about this decision? Do you think it's defendable from a public health perspective? Well, I think that the mask should be worn inside spaces. I've always said that I don't know who took that decision and why it was taken, but if we want to reduce transmission, especially in a bus or in the subway, when you are just 30 centimeters away from each other, everyone has to wear a mask because you protect not just yourself, but you protect also others. If we want everyone to be protected, we should be wearing a mask, all of it. So I do not support this decision, but I don't know what was the motivation behind it. Well, we pretend that we don't want to go into a totalitarian state. So what do you think of this, Dr. Tremblay? No, I think this is not a valid argument, really. I believe that masks should be worn in public spaces, and especially in the buses and in the subway. And people have started actually to wear those masks, and they were agreeing to do that. So I think it's kind of disappointing to change this situation. So I think the reality is that they cannot provide masks to everyone. So in such a situation, they don't want to make something mandatory because they don't really have the means to provide it, to enforce it. But, well, there are some public health measures that have to be ordered, and it's not totalitarian when you have to require that in order to protect a society. Some measures have to be set up, and that public health has the power to do so. I think it is dangerous to use such an argument. Now, in the light of what would have happened in one of the long-term care institution on the island of Montreal, when maybe there was a propagation through a poor ventilation system, do you think we should inspect all the ventilation systems of schools and within Montreal and the greater Montreal area? Well, first of all, we have to prove that this has been taken place through aerosol, that there is some transmission. There are some studies going on, so we'll know whether within the CHSLD this has been the case. And in most schools, well, either they don't have any ventilation system, it's natural ventilation, they open the windows in many schools. So I'm not convinced that you find some real air exchanges. Well, there are some schools, some cégep in Quebec when they have this kind of system. Thank you, Mr. Thériault.
We go now to Mr. Davies. Mr. Davies, 2.5 minutes, please.
Thank you. Again, to anybody who feels competent to answer this. I'm starting to read about a connection between 19 and a new multi-inflammatory syndrome observed in children. Can anybody comment on that potential connection?
Sure. So New York has reported some cases. Montreal has seen some as well. We know that this Kawasaki-like disease exists with what we think would happen also with other viruses. We're currently looking to see if children with Kawasaki-like syndrome have been exposed to the virus before. What we know so far is out of the children we tested in Montreal, the vast majority were PCR negative, and only one had a positive serology. So it's a little bit early to say, but there seems to be at least a temporal association. We now need to know if this association is causal or not.
Mr. Chair, I'm not sure if anybody can hear me. My screen is going blank here. Could we suspend just for a moment?
Very well. We'll suspend briefly.
Thank you.
Please go ahead, Mr. Davies.
Thank you. Again, to anybody who cares to answer, I think Canadians are very curious about this. What is it about SARS-CoV-2 that is making it so much more serious than any similar coronavirus? Is it its propensity to spread, its contagious capacity, its virulence? What exactly is it, if anybody can help us with that?
Well, one of the things that makes it the most dramatic is its capacity to create severe illness in elderlies. So we were kind of expecting pandemics like influenza, where you kind of know what type of population the virus is going to attack, which is broad and, of course, more at the extremity of ages. But this particular virus, first of all, is more contagious, 10 times more contagious than influenza. But for some unique reason that it is still not understood, it kills elderly. Like in our nursing homes and long-term care facilities, it's an hecatombe. So that makes it quite, and it's this interaction between host and virus that we still don't understand, because that would be the explanation for why elderly people are so fragile to this virus. So I think this is why we need to do more research on that, because this is unique.
Thank you, Mr. Davies.
Merci.
Now that ends round 2. We'll start round 3 at this point with Ms. Jansen. Ms. Jansen, please go ahead. 5 minutes, please.
Yes, thank you so much. I would really like to thank all of the presenters with all the fantastic information that we're receiving today. And I'd like to direct my questions to Dr. Quach Tan. Now, the SARS vaccine took 20 months to get to human testing phase, but was actually never developed. Now, we have human trials beginning at Dalhousie in the next 2 weeks. Does that seem too fast for you? Do you think that there should be concerns about safety?
I think what Dalhousie is starting is really a phase 1 study, which is exactly to look at what you're talking about in terms of safety. I think people just really got into high gears to bring the pre-human candidate vaccine to first in human, and that's when it becomes very important. It would be too quick if we were launching a phase 3 study, or we were going to make this vaccine available for the public use.
Okay.
But to have it in
Thank you.
phase 1, I think is perfect.
Now, as a part of the task force, the government task force, I wonder, could you tell me, do you see any ethical problems working with CanSino Biologics on the vaccine that's being developed jointly with the People's Liberation Army?
I did not think about that particular aspect of things. The vaccine is actually being tested at Dalhousie under the CERN group, not under the Immunity Task Force. I think we want to have we want to test all vaccines that could be helpful for Canadians.
Right. So do you think that we should be working with a company that's foreign rather than developing the vaccine with a Canadian company?
I don't think, so I think that there is some research that's happening in Quebec City with a Canadian vaccine. I would hope that that vaccine would also make it to the front runner line for testing.
Yeah.
But
so I guess my concern is specifically about the partnership right now with CanSino. Since until a few days ago, they hadn't published any of their findings for peer review. I'm just worried about going forward with human trials at Dalhousie. Your thoughts on that?
We now have, if I'm not mistaken, published data in the Lancet, which makes
yes, that was Friday, correct?
Correct.
So we haven't had a lot of time to really look at any findings. So I just was wondering, why are we going so quickly if only on Friday it got published? But
I suspect that the researchers at Dalhousie had some insight into the data, I would hope.
Right. Okay. So now the National Research Council signed a non-exclusive agreement with CanSino to use the HEK293 cell line to produce this vaccine. I think it was back in a number of years ago. And as such, we don't anticipate any revenue from CanSino's use of this Canadian technology. Is that correct?
I could not tell you. I don't know.
Okay, so now the intellectual property for this vaccine belongs to CanSino, so they will be able to make their own decision as to where they supply the vaccine, is my understanding. Is that correct?
You know more than I do. I don't know about the the intellectual property. I haven't looked at it.
Okay, so even though Canada is partnering with them, would they have any obligation to supply to us?
I don't know. Hopefully, but I don't know.
Okay, and why are we working with a company that's clearly in bed with a communist regime? Isn't it a no-brainer that they'll be supplying their own country with a vaccine first?
Oops. Sorry, I lost you there. Could you just give me the end of your question, because you froze on my screen?
I'm just worried that they will be supplying their own country with a vaccine first.
Possibly, but hopefully when Dalhousie decided to do this trial with the NRC, there was some impetus to also provide the vaccine to Canadians.
And I'm a bit concerned about, if we want Canadians to take this vaccine, why are we working with a communist regime? I mean, we've seen the quality of the PPE they produced under pressure, and it keeps failing time and again. I don't get why we think we can trust that it will be a safe vaccine when we're doing this all in such a hurry.
We tend as scientists to believe that science is science, that if we do good clinical trials and if this vaccine was to be approved, Health Canada would do their work in looking at the quality of the vaccine produced.
Right, but I mean, like I say, if you look at the PPE, it's really concerning. But anyways, I understand the HEK293 cell line they will be using was developed in 1973 from an aborted embryo. Is that correct?
Possibly. I haven't looked at the vaccine in itself.
Okay, is there any other way to develop a COVID-19 vaccine than with this type of cell line?
Well, you'd have to ask the scientists. I think that various platforms are being used. Using cell lines is one of those ways, and it's not the only vaccine that is using cell lines to develop or to replicate a virus. So whether or not there are other platforms, probably, but this is the first vaccine that is actually ready for human trials.
So Thank you, Ms. Jansen. We go now to Mr. Kellaway. Mr. Kellaway, please go ahead, 5 minutes.
Thank you, Mr. Chair, and hello, colleagues. And I want to thank all the witnesses for being here today. With each of our committee meetings, I'm learning so much about the science behind the virus and the research being done across the country. And it's really, really interesting to hear directly from the experts. So my question is going to be for everyone. So maybe we can go around the horn, as they say. I'm curious as to unpacking what more do you think we could be doing as a federal government to promote open science and data sharing between organizations to fight this virus together. It could be between organizations, it could be among different levels of government and organizations. So I'm interested going around. We know that more money, we've established that, which is great, more investment. But I wonder if we can unpack, what things we can be doing better right now. And as we approach a second wave of COVID or perhaps a third. So feel free for someone to start, and then we'll just rotate around the square.
I guess I can start.
Okay, thank you.
So as I said, I think one of the things we see is that even surveillance definitions are not harmonized across the country, which makes data difficult to compare. So if we could at least have an understanding of what we're talking about in terms of what is a death due to COVID and what is not a death, what is a case. So, basic things. And to do that, because we're a federation of provinces and territories, we all need to sit around that table and just make sure that we all agree. It would be also great to have a central repository of data to allow for a good understanding of what's happening in Canada, more than looking at various little points that are available everywhere.
So and common literacy, essential repository.
Absolutely. Okay. And as Dr. Tremblay said, it's hard to do it as we speak, but I think to promote long-term collaborations, build infrastructure today that will help us tomorrow to be able to collaborate is something that needs to be done. We have a tendency to try and come up with an infrastructure out of a hat when we need it, but that doesn't work. We have to have learned to work together before to be able to share data, to know who to call up on if we need help. It doesn't happen like by, clicking your fingers.
That's great. Dr. Tremblay, chime in.
Yeah, I agree with what Caroline just said, and I was also pointing out the necessity to be more acute on artificial intelligence. I mean, we don't use enough of these tools that could help bring together the research community in all kinds of different ways. You have those tools that are cool for surveillance. They need to be improved. There needs to be a next generation for that. But if we harmonize these tools across Canada, that's going to be very helpful. But more than that, like more other artificial intelligence, we all learned how to communicate through Zoom during this pandemic. So let's think of next steps in terms of communications among researchers. The other thing is, like, right now, everybody's publishing open access, that's fine, but it's going to stop at one time, and it's still going to cost a researcher $3,000 to pay for a publication, because you know that to be published, you need to pay now. It's not just that your paper is good, you need to have the money to pay it. So something should be done about that, to allow for more easy way to communicate scientific information. So these are a few things.
Thank you, Dr. Tremblay. Dr. Mossman?
So certainly at the level of being a vice president research, we've had many conversations with the U15 and with Dr. Mona Niemer about the need for a strategy, a cross-Canada strategy for big science, for to fund and have a strategy for infrastructure, so that it's not relying on these one-off CFI applications, and then and to really think about across the country these big science, and how do you fund long-term big science infrastructure. And so those are conversations that are ongoing, and I think a crisis like this just really articulates how important those conversations are.
So longer term funding, not necessarily just focused on project by project.
And coordinated as a Canadian strategy, and not just centered at who has the loudest voice and what university can get there first, but a coordinated strategy.
I've worked at a university. I don't know what you talk about when you talk about loud voices in universities, but thank you for your, sorry we didn't get to you, Dr. Wright, but I appreciate your time. Thank you.
Thank you, Mr. Kellaway. We go now to Dr. Kitchen. Dr. Kitchen, please go ahead. 5 minutes, please.
Thank you, Chair, and thank you again to everybody. And we've heard a lot from you on a lot about data collection and the challenges, and we've heard from other witnesses on the challenges of data collection and maybe lack of provision of that data, and then oftentimes that the imperfect data that epidemiologists and scientists have to make their decisions on. But I'm glad to hear from you that there at least is some effort that people are trying to communicate that. And I saw today where the Vido Intervac out of the U of S just announced on their study of where they were testing the vaccine on ferrets, and they're finding some positive results to hopefully step forward as they go through those steps into human testing. I'm wondering if any of you know, because recently Health Canada approved the first serological tests on the use of detected antibodies in those who had contracted or may have contracted COVID-19. Do you know how many immunity tests may have been performed on frontline healthcare workers in Canada? I'm just wondering if any of the researchers would know that.
You're saying how many have been done at this point in time?
Yes, yeah. And are you aware of any that may have been done on frontline healthcare workers specifically?
As far as I know, the tests are still being validated in the various labs, and so testing has not started per se. But I know that it is one of the priority of the immunity task group to know the seroprevalence in healthcare workers. I know that there was a group in BC who tested healthcare workers to look at their seroprevalence, but across Canada, something that's pan-Canadian, we don't have data yet.
Okay, great, thanks. And I'm not aware of any, but it's good to see that. And hopefully that's the group or a group that serological testing is going to be focused on.
It is.
Would you agree with that?
I reassure you, it is.
Great. On May 2nd, New York State announced the results of a completed antibody testing study of 15,000 people. Are you aware of that study, Dr. Quach? Sorry.
Oops. Yes, I've seen it. Sorry.
You have seen it. I'm just wondering, have you got any opinion on the conclusions from that study at all that you might want to share?
Well, I think that even though the epidemic seemed to have hit New York City pretty hard, the percentage of seroprevalence wasn't that high. So again, if we're looking to reach 70%, it's not happening anytime soon. And I think that Canada is even further down. So we haven't seen anything yet and are still very at risk for a second wave.
Okay, thank you very much. Appreciate that, Dr. Quach. I was reading your research support, and I'm going to ask you a question specifically, if you can comment. I noticed that one of the studies you've done is on influenza immunization. Or title of it is "Influenza Immunization for All Canadians. Does one size fit all?" And I'm wondering if you could comment. I realize the study goes till the end of this month of 2020, but is there anything you could share on that might be of interest to us to understand?
Well, I can tell you that getting data is like pulling teeth out of a mouth. And so we're delayed because the data sharing hasn't been easy. However, the goal of that study is to look at the differential response to vaccine in males and females. We think our basic hypothesis is that females will answer better, will have better immune response, but may also have more adverse events. So, in terms of local adverse events, and it just goes hand in hand. And so the goal was to look at clinical trials that have been done in the past and reanalyze the data on males versus females. But as I said, we're having a hard time getting to those data, but it'll come.
Do you see where there might be some potential for a future hypothesis on whether this might relate to COVID?
When we look at the first data out, males seem to have more mortality than females, which could also mean that their immune response might not be as strong. But it's very early on, and because we don't have a good denominator, those proportions are always hard to interpret. So it's something interesting to see. The males versus females response to infectious diseases is not the same. And so a man's cold is actually something that seems to exist.
Thank you. Mr. Chair, how much time do I still have left? Excuse me, Mr. Chair.
Sorry, you have your time is up as of now.
Oh, thank you.
Thank you. We go now to Dr. Pawlowski. Dr. Pawlowski, please go ahead, 5 minutes.
I know this has been going on for a while. It was in China. It started late December, early January. Then I don't know when it hit Italy, February or March. It's been around for a number of months. There's a number of random. In Canada, I think these have started a lot earlier in places like England. I don't know about whether Italy had them, but there's some treatments which sound pretty good on paper. And I'll ask Dr. Mossman because I think she's involved with that one, the use of convalescent serum. And then also remdesivir has been touted by some people in the United States as being a big cure now. If a study is going really well and is shown that one of the treatments is clearly beneficial, and it becomes unethical to continue that study, but all these studies are still going on months later. So I'm thinking, now am I wrong, but am I thinking there doesn't seem to be any clear benefit to.
Dr. Post, you went mute there. I don't think I heard your question.
So the question was, given how that I think there have been randomized controlled trials probably for over a month, a couple months in places like England, and yet none of them have been ended prematurely because there's been a finding of efficacy, a clear finding of efficacy. Can we conclude from those studies then that there's no great cure out there amongst the existing treatments?
So my understanding of the data that's emerging, for example, from the study in the States on remdesivir, is that it's okay. It has some efficacy, but certainly what we know from other viral infections is a single agent as an antiviral. Often, even with some efficacy, the virus will quickly mutate around that. But I think as we understand what cocktails we can use, similar to how we've used cocktails for HIV, a cocktail approach, even if each individual antiviral drug is okay and not spectacular, a cocktail approach is often very useful. As far as convalescent serum, there are a number of studies that I understand or in instances where they've used convalescent serum and seen some efficacy. Certainly at McMaster and across Canada, there's a new study starting called the Concord 1 study, which is in 60 or more than 60 hospitals, where they're specifically going to have sufficient power to be able to really understand the convalescent serum, and also be looking at, along with that, the levels of the antibodies and trying to understand not just are there antibodies, but at what levels, how efficacious are they, so that we can better understand if it does work, why it's working, and how it works.
Now, I think one of the big conundrums with this disease is why children don't seem to be affected very much. Now there's talk about this being an etiological factor in Kawasaki's disease, but that seems unclear at the moment. So it seems like a really interesting question why they're not infected, or why when they get infections, they don't seem to get really sick. Is there any possibility that having had another coronavirus recently protects you from a different kind of coronavirus? Because we know that coronavirus is a fairly common cause of the simple cold. Is there any cross protection from one form of coronavirus to another?
There have been some studies that have looked at that, and there's certainly some studies now where they've also looked at patients that were infected with the original SARS, so SARS-CoV-1. But again, in those studies, the immunity really only lasts for, say, 2 to 3 years. And so even though there's potentially some low levels of protection, coronaviruses don't generate historically long-lasting protection. And children have a very high natural immunity. Their immune system, is often quite active, whereas that wanes as you get older. So part of it could be why children and young adults aren't getting as severely ill is they have the most robust natural or innate immune response.
Thank you, Dr. Pulaski. We go now to Mr. Desilets. Mr. Desilets, please go ahead. 2.5 minutes.
Merci, Monsieur le Président. Merci.
Thank you, Mr. Chair. Thank all the witnesses to share with us this fascinating content. You're giving me a desire to go back to study medicine. My question then is to Ms. Tan. We have heard about the difficulty in sharing information, the difficulty in compiling this epidemiological data. Now, in your opinion, which agency or which individual in Canada should have that responsibility? Who should take charge of that issue? Well, that's a very good question. Unfortunately, I don't have an answer. Otherwise, I think I would have put it forward earlier. I think the PHAC has definitely to play a role. I think the agency, the Public Health Agency, is trying to play that role, but at the provincial level, the data is within provincial jurisdiction. I know we've tried to reach some agreements amongst the parties, but it doesn't really seem to quickly facilitate data transfer, at least not in real time. The data gets there in the long term, often with 1 year delay. I don't really understand the Canadian Constitution well enough to explain how these kinds of data should be transmitted directly, but I can tell you that from our end, things are not really working. We have heard that from several agencies, so there seems to be a strategy that has to be developed, and that's important. We've heard you say that often. Maybe another question for you. In your opinion, Montreal, that has a very specific situation, do they have more of a chance to have a second wave or a second peak with this virus? I think this is coming fairly quickly. if the deconfinement is poorly done, as what we see in the southern United States, Texas, Georgia, Alabama, they are starting to see increased numbers in COVID cases. If this deconfinement is done poorly, if we don't maintain the physical distancing, mask, we could see an increase in the number of cases. So we must continue testing. That's very important. The population must follow the recommendations. So we'll wait and see. Thank you.
Mr. Davies, please go ahead. 2 minutes and a half, please.
Thank you. Dr. Quashtan, you have stated that a challenge trial is what will give, from a scientific point of view, the quickest answer to all kinds of questions, whether it's the effectiveness of a vaccine or the risk of reinfection or what the immune response is. I'm just wondering if you could briefly tell us what a challenge trial is and where Canada is at with respect to conducting them.
So by opposition to just a regular randomized controlled trial where you would vaccinate a patient and wait for that person to be exposed to the disease to see if the vaccine would be then protective. A challenge trial actually is when you squirt up the virus directly in the nose of a person who's been vaccinated or not to see if those vaccinated are more protected than those who are not. In terms of challenge trials, we haven't done any in Canada thus far with any virus, but there are two challenge units that have been built as part of a CFI, one in Dalhousie, where they are doing that first phase 1 study, and one at the MUHC in Montreal. Those challenge units were built to try and do studies on influenza vaccines after vaccination, but none of them were done. So I think that to do a challenge trial, you would need at least to be in phase 2 or 3 of a vaccine, because before that, you're still, studying the safety of the vaccine and its immunogenicity. But instead of vaccinating and then just, letting people be and hoping that they get exposed soon enough to see if that vaccine works, that's when a challenge trial happens. They've also done that for norovirus vaccines.
Do you know if anybody in the world is using a challenge trial process right now?
For COVID, no, not yet. But there were papers published for gastroenteritis vaccines.
Okay, and finally, Dr. Bonnie Henry, British Columbia's Chief Public Health Officer, stated recently that there has never been in history the case of a pandemic that did not have a second wave. So if that's the case, I'm just wondering if each witness can tell us what their number one prioritization would be to help prepare for that inevitable second wave. Perhaps we can start with Dr. Tremblay.
I would make sure that our nursing homes and long-term healthcare facilities be totally transformed before the second wave. I mean, we just haven't finished the first wave. We're still seeing mortality in these centers. And if there is a second wave, nothing is going to change because nothing has changed in terms of more personnel, more ratio, preparedness, ventilation, nothing has changed. So this pandemic has been deadly for this patient population, not for the rest of the society, not for us. It's been deadly for elderly people. So we need to do something quick for these people.
Dr. Wright?
Thank you, Mr. Davies. That brings round 3 to a close. I'd like to thank all of our witnesses for all of your sharing so much of your time with us today, and for all of your presentations and your excellent information. Thank you to the members, and with that, we will adjourn. Thank you.
you.